We are going to do a few questions on lesson 3.3 assignment, just to help guide you and help you think through some of the ones on your assignment, on your homework. So you can use this maybe as you're going through the first section, 1 through 9. You could watch me do number 2 and use that idea to help you with the others. Same thing with number 12 for the next group and number 14 for the next group, and then 20 and 22 and following. So in the first set, it says identify each natural number as prime, composite, or neither. Well, prime means its only factors are 1 in itself. Neither just means the number 1. The only natural number that is neither is 1. And then composite, it has more factors than 1 in itself. Has more factors than 1 and itself. All right, so as we look through here, if we ever see anything that just has more than 1 factor, then we automatically know it's composite. So they don't really have to take a lot of time in those cases. If not, we have to work through and look at our different prime numbers to see if anything goes into them. So number 2 is 53. Now 53 I don't recognize immediately as or something that divides into it. So I'm going to check, and the first thing I'm going to do though is I'm going to remember that we don't need to check over the square root of 53. Well, the square root of 53, remember that's close to the square root of 49, which is 7, so we don't have to check over 7. We are going to check, and you should get an idea of these prime numbers. 2, you should be able to list the first several, 2, 3, 5, and 7. So really all we have to do is check these 4 prime numbers. And this is where you use your divisibility test. So does 2 go into 53? Well, no, it doesn't. For 2 to go into it, it would have to end in an even number. Does 3 go into 53? Well, remember for 3, we add 5 plus 3. 5 plus 3 is 8. Does 3 go into 8? It does not, so therefore it doesn't go into 53. 5, once again, we look at the last digit, would have to end in 5 or 0, and it doesn't, so 5 doesn't go into it, and then we check 7. And for 7, we're just going to divide. And some of you might know already that 7 does not go into it. And that's fine if you have that knowledge. You don't have to show the work. So there's a remainder 4, so 7 doesn't go into it. Well, if none of those numbers go into it, then number 2 is prime. I also want to show you how easy this can be, so we're going to slide over and do number 4. 4 is 124. So we want to know if it's prime, composite, or neither. Well, it's even. And we know that 2 goes into any even number, so therefore it's composite. Not much work to show. As long as you know that some digit goes into it, some number goes into it, then it's composite. So work through those, 1 through 9, the odds. All right, jumping down to the next section, it's a little shorter. We're going to look at number 12. It says find the prime number in each list. Find the prime number. Well, what I would do is I would go through immediately and just cross out anything I know is not prime. Well, 81, that's a familiar number. That's 9 times 9. I know that's not prime. 87, 91, 97, I'm actually not as familiar with those. So I'm going to just work through and try some of the tests to see if they are prime or not. So 87, I do actually see this pretty much right away. 8 plus 7 is 15, and 3 goes into 15, which means 3 goes into 89. So 3 goes into 87. So 87 is not prime. 91, we can check 3. 9 plus 1 is 10. It doesn't work. So let's work with 91 a little bit. The square root of 91 is close to the square root of 100. So we're going to try up to 10. Which if 5 doesn't work and 2 doesn't work, 10 won't work. So, but anyway, for 91, we're going to try 2, 3, 5, 7, and those are the only prime numbers under 10, so we just have to try those. So we know 2 doesn't work. We already talked through 3. 9 plus 1 is 10. 3 does not go into 10, so 3 doesn't work. 5 doesn't work because it doesn't end in 5 or 0, so let's try 7. 7 into 91, it's 1. 1 times 7, 2, 1, and it goes into it 13 times. So this one is not prime. I don't know why I circled it. I forgot what the directions were. Find the prime number. So 7 goes into this, which means 97 has to be the prime number. So you can use that idea for number 11. For numbers 13 and 15, find the composite number in each list. What I would do first is just work through and see if I know any composite numbers in there. So if not, then you'll have to go through and divide to see if they are prime or not. Kind of going through what we just did with 91 on the list before, but here we're trying to find the composite number. So in number 14, I'm going to just think through here. First, 71, 73, 77, and 79. Actually, I'm familiar with 77. 77 is 7 times 11, so I know that's composite. And so my answer is 77. And again, for 13 and 15, you might need to do some dividing and trying things out. Down to number 20 and 22, we'll do that one. So these, it says, write the prime factorization of each number by using exponents. So what we do, I'm going to do each of these differently. So 48, I'm going to go ahead and do the factor tree. There's a lot of starting points for 48. We could do 2 times 24, 6 times 8, or 4 times 12. Oh, let's go 4 times 12. That's actually what I thought of first when I saw this one. So 4 times 12. And then 4 is 2 times 2. And 12 is 4 times 3. But 4 is 2 times 2. Sorry about that. It's pretty small. So we have 2, 2, 2, 2, and 3. And I'll just rewrite that in a minute. So 48 is 2 times 2 times 2 times 2 times 3. But this question asked us to write in exponential form. So this one here, this is those 4, that's 2 to the 4th times 3. So there it is in exponential form. And now I'm going to do 22. 22, the number was 120. And I'm going to do the factor tree this time. So 2 definitely goes into there because it's even. So 2 into 120, that's 60. Well, we still have an even number, so we can do 2 again. 2 goes into 60 30 times. Still have an even number, so 2 can go into that again. 2 goes into 30 15 times. It's an odd number, so 2 doesn't work. What about 3? Well, yeah, 3 goes into that 5 times. And 5 is a prime number. So I usually stop there. The book actually went one more and said 5 goes into that one time, but as long as I end with a prime number, you can stop there. And so, let's slide this over. Our prime factorization, 120, is 2 times 2 times 2 times 3 times 5. I got that from these over here. But we want exponential form, so this is 2 cubed times 3 times 5. And that is our answer. That's the prime factorization for 120. And looking at the last group of questions, 28 to 30. So you just have to do 29. It says, name the composite number that corresponds to each prime factorization. All that's asking you to do is multiply that out to see what that's equal to so you know what composite number that is. So I'm going to do both 28 and 30, and you will have to do number 29. So what I do is take care of the squareds first. 3 squared is 9. because that is the order of operations to do squared terms first. 9 times 11, and then 9 times 11 is 99. So that's the composite number that goes along with 3 squared times 11. And then number 30, once again, I'll take care of the exponents. 2 cubed, that's 2 times 2 times 2, which is 8. And then we have a 3, and then 5 squared. 5 times 5, that's 25. And now we can work our way across. 8 times 3, that's 24, times 25. And 24 times 25, we might have to work that out over here. 0, add the 2. 8 plus 2 is 10, 0. 0, add the 1, and we get 50. And so this is 600. And we see that 2 cubed times 3 times 5 squared is 100. So that's the answer. I want you to see something here. You actually can pick out some things that are sometimes helpful, and you can multiply a little quicker. So one thing that we know is that 2 times 5 is 10. And by now, I think we should be pretty good at multiplying by powers of 10. So if we look here, this is 2 times 2 times 2 times 3 times 5 times 5. Now we can multiply in any order because of the commutative property. So 2 times 5 is 10. And then 2 times 5 is 10. And 2 times 3 is 6. And this is stuff you could all think of in your head. I'm just writing it out so you see it. But we have 100 times 6, which is 600. So there's a mental way to do it. I know I wrote it out, but you could do that mentally. All right, do great on your homework.